we're considering graphing functions that are made up of two other functions, right? So you've got some function, right? And what it is another function, plus or minus, still another function, okay? Now, we'll start off with some examples of functions that you can figure out without doing this, that you can use our rational functions methods from before. But we're going to progress into methods where when you look at this, the whole function as a whole, right, you really can't do much with it. So you sort of have to resort to looking at these two, I suppose you could call them component functions, right? And thinking about what these two do and then putting them together, okay? So let's do our first example. Let's consider y equals x plus, let's do 2x. Okay. So what would this thing look like? Now, like I said before, I don't have to consider this as two separate functions if I don't want to, right? What I could do first is I could get these on a common denominator, right? So this would be x squared on x, and on x is my common denominator, yeah? So I could treat this as x squared plus 2 on x, right? And then you could do your normal rational functions business with it, and it'd be fine, okay? However, I want to teach you the tricks that work with these two, right? And treating them separately, so that when we get to stuff like, say, this, right? Which you can't put together into a nice, neat rational function, you'll know what to do with it. Okay, we'll get to this in a second. So the way we treat these two is by graphing them first. So if you've got another color on you, or just use your pencil and do it lightly first. Let's graph these two and see if we can add them together. Okay. So y equals x. Okay, now I'm pretty sure my scale looks pretty awful here, but in a sense, it sort of doesn't matter for now, because I'm just using these as sort of guideposts, okay? Alright, now, I'm trying to add these two graphs together, right? I'm trying to add them together. So what I want to think about is to visualize what each one is doing, and then see what happens when I add them, okay? So, example, we'll start from the left-hand most side, and we'll progress all the way to the right, okay? What's happening over here? What's happening over here? How would you describe each graph? Well, you've got a negative value, right? And it's sort of an ever-increasingly negative value. And another negative value, but this one's really small, right? Big negative value, little negative value. So when you add them together, what would happen? We'll take from the more important factor and then add the smaller, less important factor, okay? From this one, do you think my result, when I add them together, would be above or below this line down here? Below. It'd be below, right? Because that's the effect that this negative would have, okay? So in fact, you could literally get your ruler out. That's weird. It's over there. It's hiding from me. You can literally get your ruler out if you've drawn this well enough, which I haven't, and say, well, okay, at a point like, say, here. Okay, suppose you measured that distance there between that little gap and saw it was like, I don't know, a centimeter. Okay, so then you would say, well, that means this centimeter will translate to a centimeter down here where I should be. Let's make our line straight first. Lower. Does that make sense? Can you see? So negative plus negative equals more negative. Okay. Now, what happens is I go towards the right. Okay. I've got one line that's increasing, getting closer to positive, and the other one which is decreasing. It was negative to start with, and now it's getting more and more negative. Okay? So as I move to the right, the question I ask is, which one is more important? Which one takes over, as it were? Okay? So you saw when I looked at this point here, this one was a more significant value than this one up here. This one's almost negligible, right? But over here, the game changes, right? What happens? This curve here, the 2 over x, right? Sorry, here it is. It becomes a more significant value, a more significant part of the function, Okay? I'm going to use that language a lot, more significant, less significant, because I'm kind of trying to get the general shape of things. Okay? So again, instead of going closer to this line, I'm going to go closer to the more significant one. Am I going to be above or below it? Again, I'm going to be below, right? Because to the left of this axis, everything is negative. Okay? So you could take your ruler again, measure down, and take a point like, say, here. It should be below. Okay? Now, what happens in between here? Well, I can tell you what it's not going to be. Okay? It's not going to be a straight line. How do I know it's not going to be a straight line? Because it sort of looks like, you know, from here to here, I could just go straight across. Okay? How do I know? How do you know? It can't be a straight line. Because there's a curve here, right?
Another curve that's counteracting.
Good. Okay, so I'm trying to get this interaction between two different functions, right? And true, if I had one curve that was going up like this, right, and another curve that was going down like this, because they're both curved, and they're both going equally, they would cancel each other out, right? But it's not the scenario we have here. One's curved, so in other words, it's decreasing rapidly, right? And it's increasing more rapidly as I go. This one's increasing, but it's not speeding up, it's just chugging along at the same rate. Okay? So therefore I'm going to get a curve in here as well. So I'm going to get something like this. Okay? Now, I've put arrows on the end here because I know I'm going to get some asymptotic behavior. The question for you is, how do I know? How do I know there are asymptotes? I'm describing two. Number one over this way, and number two, one down here. Okay? So I'm